Good afternoon, IM9 students, or good morning. This is your virtual day lesson. It is notes part 2 of your exponents packet. So please turn to the page that you see on the screen. The first part of the lesson is going to ask you to talk about the the zero exponent. And then you're going to talk about negative exponents. These last ones, rational exponents and radicals, we're going to save for a later date. Okay, so you can cross those off. It asks you to evaluate these expressions in your calculator, and when you go and do this is 5 to the 0, you're going to find that that answer is 1. Negative 4 to the 0, that answer is 1. 0.04 to the 0, that answer is 1. And 3/4 to the 0 is 1. The one thing I want you to notice that please pay attention to the parentheses around these if they have parentheses, because what you're going to find is that if I gave you this one here, and I did not put it in parentheses, and I said negative 4 to the 0. Well, you might think, well, it looks like any number raised to the 0 power is 1, but this is not. What it actually is negative 1. Your calculator is doing the correct order of operations. It's doing 4 to the 0 and then taking the negative of that. So the parentheses are very important in these cases. If you're going to substitute into something, make sure that you put it in parentheses. Okay, so here's this zero exponent rule. It says to study these results, kind of like we just said, it seems that a base raised to the 0 power is 1. Okay, the base could be a number, it could be a variable. Now there's one exception to this, your base cannot be 0. Okay, if you do 0 to the 0 in your calculator, you'll get an error. So what does this mean? Well, if we take x to the 0 power, that gives us an answer of 1. Okay. All right, we're going to move on to negative exponents. So it gives you a bunch of examples down here. You have 4 to the negative 1 is 1/4. 3 to the negative 2 is 1 over 3 squared, which is 1/9. X to the negative 1 is 1 over x. And 2/5 to the negative 1 is 5/2. Y to the negative 5th is 1 over, y to the negative 5 is 1 over 5. If you look at these, you start to notice a pattern. Now, most of these, 4 to the negative 1, 3 to the negative 2, x to the negative 1, and y to the negative 5, are all written in the numerator. They're not written over 1, but they could be. Then it seems like they're always moved to the denominator. That's kind of the pattern that we're going to see. So what we're trying to do is our answers don't want to have a negative exponent in them. So if we come to our homework tonight and we have a negative exponent, we haven't finished the problem. Okay? So study these problems. What does it say? It says that the negative exponent rule is this. To make a negative exponent positive, you're going to move the power. Now remember, the power is both the base and the exponent to the other side of the fraction and make the exponent positive. What does that mean? If I have a negative exponent in my numerator, I'm going to move the power to the denominator, and then the exponent becomes positive. The base does not change. Okay? If I have a negative exponent in the denominator, I'm going to move it to the numerator and make it positive. So what does that look like as a rule? It looks like this. There's two different examples. The first one, x is in the numerator, it moves to the denominator. Second one, x is in the denominator, it moves to the numerator, and notice that it's only the exponent that changes signs. So what does this look like as an example? Well, 1 over 5 to the negative 2. Well, 5 to the negative 2 is in the denominator. I'm going to move it to the numerator and make the exponent positive. Now, I could write this as over 1, but we know that any number written over 1 can just be written as that number. So 5 squared over 1 gives me 25. 1 over k to the negative 5 becomes k to the 5th, and again, I could write it over 1 if I wanted to. Okay. So why don't we go ahead and try a couple of these examples that are down below. Now, some of these examples are going to involve using rules you've already done. Okay. The first one doesn't, but the second two do. For letter A, we have s to the negative 5 t squared. It is only the base of s and the exponent of negative 5 that are negative and have to be moved. So since they're in the numerator, I'm going to move them to the denominator and make the exponent positive. The t squared is already positive and it's in the numerator, so it stays in the numerator. I will sometimes do this, where you'll see me circle what is going to move. That way I don't miss something when I'm moving a bunch of stuff around, because these are going to get a little bit more complicated with more numbers and more powers and stuff. So sometimes that can be helpful so that you don't miss something. All right, letter B you're going to have to apply one of the rules that you learned before. You learned that when you are multiplying powers with like bases, you add the exponents. So if I have x squared times x to the negative 3, that's going to be x to the negative 1, because 2 plus a negative 3 is negative 1. Y to the negative 3 times y to the 5th is going to give me y squared. Now it's only this x here that's raised to the negative 1 that's going to have to move. Y squared is going to stay in the numerator. X to the first, or just x, is going to be in the denominator. In letter C, this is a power to a power. What this means is going to take the negative 2 and I'm going to distribute it into that base. Okay, so I have 2 to the negative 2, and when I distribute it, I'm going to multiply the exponents. So x to the negative 6 and y to the 4th. These ones right here, the 2 to the negative 2, x to the negative 6, those are the ones that are going to have to move. Y to the 4th is going to stay in the numerator. 2 to the negative 2 is going to become 2 squared in the denominator, which is 4. I'm going to change it right away. And then x to the 6th. And that's my answer for letter C. Okay. One thing I want to note off to the side here is it's a common mistake for students who are first starting to do this to want to change a negative base to be positive as well. But remember, it's only the exponent that's changing. So if I have negative 3x in parentheses raised to the negative 2, this can be written as 1 over negative 3x squared. Notice that the base of the negative 3 did not change. And then from there, I can simplify using my power to power rule. And this would be negative 3, again, leaving it in parentheses because that's where it started, squared, and then x, again, squared. Negative 3 squared would be 9, because negative 3 times negative 3 is 9, and then x squared. Okay, so just make a note of that. That's a common mistake that I see. Okay, when you are done with this, I would like you to create a note card if you have not already, or if you started one, to add on these two rules. You should have a total of, I believe, 6 different rules that we've taken over these last 2 class periods. You should be writing the name of the rule along with an example on that note card. This note card can be used to kind of help you through the homework. Okay, it's putting all the rules in one nice spot for you. Okay, when you are done with that, please turn to this page, which is the day 2 homework. And yes, it looks a little bit longer, but it is really, actually, this is one of the things that practice is very important for. So turn to the day 2 homework, and that is your homework. Again, for virtual day, this homework needs to be done because this is the way we take attendance. If this is not done, you get marked absent for our class. So please make sure that you complete this. Okay? Enjoy your virtual day. If you have any questions, please email your teacher.